My name is Sanjay Misra, as he introduced me. I work in a company called Microsoft. Anybody here has heard about a product called Microsoft SQL Server? Okay, Microsoft Azure SQL. Okay, I'm the head of product management for those set of products. So, okay, so then sometimes I see that people have a little bit of confusion about, okay, what is AI, what is generative AI, what is machine learning, and then on and all this space. So I try to get a picture from NASA of our galaxy and try to kind of put this together in a frame. You know that our solar system resides in a galaxy called Milky Way. But within Milky Way, there are many branches, many arms of the galaxy. And one of the sub-arms is called Orion Spur. And in that Orion Spur, we have our solar system in which our Earth resides. So you can see that AI is the Milky Way, machine learning is the Orion Spur, deep learning is our solar system, generative AI is Earth. That's the kind of thing you can frame it. Then you can say, okay, what is data? Any guesses? Data is the universe. All of these reside based on data. Okay. So now you can imagine what we are thinking of as a secret sauce is actually the source and sustenance of life. Okay. Now let's move on. How you can use data to make better AI, or how you can use your business data to make your customers' life more interesting, more useful, make your business more successful. And so, for example, let's ask this question: help me plan a high school graduation party. Right? Recently, like last 2-3 months, there have been a lot of graduation parties in the neighborhood or friend circle that you probably live in. A lot of people are graduating from high school, going to college. So if you ask this to AI and pick your AI, in this case I'm using Azure OpenAI, and if you ask them this question from your favorite tool, you all know you can put a prompt, you put the question, you give it to AI, and AI comes back with this data. In this case I'm using GPT 4.0, and we get an answer. When you get an answer, the answer will be something like this. It's pretty interesting. It says, okay, yeah, you should plan for decoration, you should plan for food, you should plan for, it's also even suggesting actually that you can plan for a DJ. But what is it's doing is that it's giving me product IDs. There are fake product ID 001, 002, and what does that means? I cannot go buy any product 001, 002. So this is meaningless to me. It's even recommended that, okay, hire a DJ because high school kids want to enjoy the DJ and the music and dance. So this is interesting, but not very practical. I cannot go to a store and buy product this, right? What if you are Walmart? Because you sell all those stuff, you sell decoration item, you sell food, you sell, so what if you can actually use your own data to inform the customer what exactly they need to buy for the graduation party. Now, why I'm picking on Walmart? Because they have published an awesome set of data on Kaggle, and I'm going to share the link here. You all can go actually download the data, put that into your favorite database, and have fun with it. So with that data, what are we going to do? If that data comes in, this is the Kaggle link, by the way. This data comes in this kind of structure. It has got the product names, it has got product description, it has got a bunch of stuff. Now, this is business data, this is actual product data. You can use this as your secret sauce to make the interface that you are exposing to the customers, to Walmart's customer, more productive, more intuitive, and make your business more successful. So let's do that together. So what we are going to do that in a couple of steps, because we have all the product data, and we are going to create an embedding for each of those product rows. An embedding, as you know, is a vector representation of a text, as simple as that. They call it large language models, isn't it? But they don't understand language, they understand only numbers. And those numbers are actually vectors, right? So this is the irony of things. So sometimes don't go by the name, go by the semantics of it. So now we are going to create all of them, and we are going to actually store in a column called product description vector. Okay. In my case, I am storing them in a var binary 8,000 columns. Some databases have a data type called vector. In Microsoft SQL product, you will soon see that called a vector instead of var binary. But Don't worry about that. We can store vectors there. Now that I have stored the vectors, what I'm going to do that, I'm going to get that question and get the text embeddings like this and store it in the database. After I have stored them in the database, we'll do a vector similarity search. You all are familiar with vector similarity search, right? What you're going to do is that you're going to say, okay, this is my question, get me the vector of that, and here are my products, go against all those vectors and tell me who are the closest matches. As simple as that. And when you do that, you'll get a set of answers like this. Much more productive answer. You have a product ID, you have a name of a product, and so on. So now you can actually send this data to the LLM and say, now summarize this for me. What all products I want? Do I need many of those, 5 of those, 10 of those? And then you get your question, which is help me arrange a graduation party. Context is the data that you got by doing similarity search. You send it to a completion model of ChatGPT 4.0 at this 4.40 for this example, but send it to your favorite LLM, and you can get a completion answer back. And I walk through the whole example with actual code in this blog, so you can take a note of the blog, and then you can do that. The code samples work for Microsoft SQL. You can slightly tweak it and work in your own flavor of SQL as well. Okay, so you'll get an answer, and you'll get an answer like this. It is, see, it's very similar structure, very similar format, but it does exactly tell you that, okay, by the pack of 12, Mardi Gras theme, this thing, buy the Megalodon set because that's good for decoration. It's actually giving me the actual product ID. So you can actually go, and tell a store that give me these product IDs, and therefore think of this as an Walmart. If you are the business, you can use your own data and the power of AI to make your customer life much more actionable. Now you could interface this, and you can, your phone app could actually go do that. You send a question, it will actually not only tell you things, it will tell you go buy this many, buy this one, buy this one. It can actually also filter on that this item is in the store. If it is not in the store, either replacement for it, and as a result, you as a customer get the benefit, your business gets the benefit. Exactly. Thank you for bringing that up. Thank you for bringing that. So what does it mean? That LLMs can do certain things they are not supposed to do. This is AI, right? Therefore, most AI co-pilots, everything that you use these today, AI assistants, there will be a disclaimer somewhere. This is AI generated thing, be careful using. So that's what you need to be careful about using, like with any AI. Which means that if I give you a knife, you know where to hold it. You don't hold on the other side, okay? So that's as simple as that, nothing more different than that, right? So that's it. So thank you for catching that. Any other question before I move on to the next interesting thing? Yes, sir. Yeah. Yeah. Thank you for asking this question. That actually is a very good seeding for my next topic. So good. Okay. How can you? So the question that was that is that if I had to look through the whole table, that means the context is very high, and first of all bandwidth concerns, first of all data processing concern, and tokens concern in terms of sending the context to the LLM. How do I kind of filter it, narrow it in a way so that I can get the best out of the what? Yes, sir. Correct. So this workflow pattern is called RAG. Retrieval augmented. I didn't want to use buzzwords to kind of do that, but this is what is RAG. As you can see this. Okay, I'll come to the because next example exactly answers that. Okay, so let's see what else we have. Where is okay. So this is where the blog link where everything you will see there. Now what happens is that because your data sets could be very high, your search space could be so high that doing this on your entire set of data would be very inefficient, and that's where the smart data people come into the picture. What do smart data people do? they know how to write queries, we can actually filter things in a very efficient way. They know how to write good queries, they know how to write very good semantic queries that actually does the filtering corresponding to the actual ask. So that's what I'm actually going to do. Good part is that the databases are very strong in this. You can use equality filters, you can use inequality filter, something more than this, something less than that. So for example, in the Walmart example, you could have used select that data only if it is available in the store in my zip code. So you could use those as an, so we can actually augment the RAG even further. We can augment the vector search even further to make it more useful, more productive, and more efficient. So this is what we are going through. So you can use the databases that are capable of that kind of search. Many databases allow you to do regular expression. Microsoft SQL does allow you to do that. Many databases come with geospatial capability. That means you gave my zip code, I could also give 5 miles within my radius. And the database I'm using in this, for example, has a very strong geospatial capability. Many databases have. So use them. So because what's the fun? Because if the party is tomorrow and this particular megalodon is available in 180 miles, no use to me, right? So that's what you could use all these things to make your life easier as a user, or you being the builder for your users. And graph capabilities. Oh, I want to use it only if my friend has used it, right? Because I went to their party and I saw a very nice decoration. So you could use those things also to influence your search, narrow your search, so that you can ensure the right context. Okay, so what we're going to do this, I'm going to search for focaccia bread. Okay, everybody here know focaccia bread? And I have intentionally spelled it wrong. Okay, I'm a person of Indian origin, spent last 25 years in the United States. My pronunciation of an Italian item is obviously may not be correct, and also if I try to translate from that pronunciation to a spelling, Italian food is spelled, right? So I said, okay, but the good part is that this is where AI is good at. AI is forgiving. AI can actually forgive me for my spelling mistake and actually get me to the nearest, closest thing for what actual focaccia bread is, and we're going to play with that. So in town, and you can imagine the kind of examples. Okay, so this is why vectors are important in modern relational databases, and this is why vectors need relational databases, because all those augmentation techniques that I talked about, equality search, inequality, if it is a pure vector database that doesn't know relational algebra, if it is a pure vector database that doesn't know how to do graph, if it is a pure vector database that doesn't know how to do geospatial, then you are, unfortunately my friend, you are burdened with that whole database context, right? But relational databases are very powerful in that. They have been doing that for decades, and they have a query processor which is very optimized to do that. So if you give them these things, they can make your life easier. So let's get the best of the relational databases, the best of the AI, and let's build it. So now what we're going to do is we're going to do this. So I'm in London and I want to find focaccia bread. An Indian origin person having spent 25 years in the USA is in London trying to find an Italian food. Okay, so you can imagine that kind of a cultural context here. The good part is that I have the data, your data, that data is the most powerful thing. So this data is like think of this like a Yelp kind of review thing where the products, restaurants, or any businesses, and they have the review. I have them in these two databases, these two tables in the database, which you all are very familiar with, right? Now I have these conditions. I'm in London, so find me in London. I'll do that through equality search, city equal to London, nice where clause. I want within 5 kilometer radius. I'll use a geospatial of where my current location, take the geometric location from that one, at 5 kilometer radius, because London traffic is very bad. I don't want to go 20 kilometers to find it. And I understand that, okay, this is available in usually Italian food. If I find a category of the restaurant, I may be able to do a regex kind of filtering and then go only to Italian places. There is no point going to an Indian restaurant in London asking for focaccia bread. You will get naan bread there, okay? No point in going to a Mexican restaurant and then asking for a focaccia bread. You will get pita bread there, or you get nachos there. So that kind of human in the loop can actually help filter, right? Now I don't want to go to just any place. I want to go to a place where people actually like it, right? So the reviews are actually greater than 4 on a scale of 5. And also I do not want that somebody's cousin has gone and then ate in that place or not ate in the place and wrote a review with a 5-star. Enough number of people have gone. So it's a truly popular place, truly good place, and they do it. More importantly, I'm looking for focus here bread, right? And this is another wrong spelling here. By the time I had my intention and by the time I'm trying to write my design, I've already forgot my own spelling mistake. So another spelling mistake here. But what I'm going to do is that I'm going to use that for a similarity search, and this is where the similarity keyword comes into the play, because I'm looking for something similar, not exact. If it was exact, I'll not find anything. I'll go hungry. But since I'm looking for something similar to focus here, it will ignore my spelling mistakes and it will take me to a place where I can put focus here. And I'm going to use generative AI, and I'm going to use this technique, other predicates plus similarity search and hybrid search. After I apply all these filters, I don't have to send my entire table, because you know these are 6 million and 8 million rows in this table, and I have to look into both the tables together, because some has business, some other has review, and if I have to do the whole context, LLM will give up, right? And or it will take a long time.
Yes. LLM will line up does that kind of thing.
We'll get to that. So that also will come. That will also will come. Let's empower our data people right now, because data people know how to write queries, right? So they will do the query. We'll empower them first, then we'll empower the people who need a little bit of help. So this is what so this is a demo. This is a recorded demo because I wanted to be not subjected to any kind of a Wi-Fi hiccups. So you will see, and I'll talk through that. We have 2 tables where we have the data, and you can see what I talked through. I'm adding the filters, I'm adding the star level filter, and then I got some data. Once I got some data, I'm also looking at which place to look at. I see that, okay, there is a categories column where the restaurant types is written. So now I know that I have to add a regular expression kind of to parse that and then to come up to narrow down. I'll do that. I also need to narrow it down to 5 kilometer in radius in a geographic radius. And so this is the geo location, and then that also reduced the filter a bit. Within that geolocation, I see, okay, there are some places which has got Italian, but there are some places called, they just sell gelato, okay. I don't want to go there because you will get gelato, you will not get bread. So you can use that kind of your knowledge about the data to augment your queries better. Now after I get that, I get a much narrowed down subset of the data, still not done, right? So I'll do that, and then okay, this part we have seen, and the next part is that this is so far regex and other filters applied, and then what I'm going to do next is actually I'm going to do the the generative AI part of it. Everything has been encoded into a vector column. Now I'm going to get embeddings using a text embedding 3 small model. I'm going to call Azure OpenAI, and see it has got thick focus here bread, and again you see the spell is wrong, right? This is going to take it. This is actually the function which is calling Azure OpenAI and passing on my question that get me focus here bread and getting me the answers, and it's going to get a response as a JSON output, and we're going to parse the JSON to get the final result. So so while getting the output, we are going to actually compare to do the similarity search. Every business and every review has an embedding, and I've got an embedding for my question that I asked, and then we're going to get a set of results. Now what happens is okay, still going on. So this is all the filters together combined here, and above this, if you see to the top here, yeah, so that's where the embedding part is also added. So that means the filters you need for your similarity search and the other predicates, they are all part of the same query. They can all be applied to the database, and the database is going to respond with me to the much narrowed down smaller set of answers, and this is what it got it. Now see, not just me, even people who ate there, they also spelled wrong focaccia bread. Okay, but good part is that AI is able to find the similarity that they meant focaccia bread. The question the person who asked the question and the person who put the review, none of them are correct, but finally I got what I wanted. So that's how you get the actual help from generative AI similarity search along with. Okay, so now we'll go to the next. So the next goal that we have is actually we got all the reviews, basically packaging it together, because you know the search is going against the reviews, because in review people are saying I like the focaccia bread here, I went to good parties, I like everything good here, but the focaccia bread is bad here. There's a good review but bad on this product. So you'll see that the LLM is going to parse that. And now I got all the list of the reviews, and then I'm going to get the combine them together. I think this is yeah. Now that we got these results, yeah. So what we got the correct reviews, and we got the. But if you see, the same business is showing up multiple times because multiple people have reviewed it. To package my result to the end user, I don't need to tell them go to this place, go to this place, go to this place. I'm just going to what I'm going to combine them through, again, we are all data people, we know how to combine rows, we know how to aggregate rows, and through that what I'm going to JSON aggregate, I'm using the JSON aggregate capability to combine them and send a result back to the user that okay, oh, these are the 2 or 3 businesses within your search criteria, and search criteria is what? In London, 5-kilometer radius, Italian place, 4-star reviews and at least 30 reviews. So it will do all this stuff and give me this data output back. So this is much more effective, much more powerful, much more meaningful for your useful. So okay. Okay. So this is how we did it actually. So you got we had a data set to start with. How am I doing on timing? Okay, good. So we took the data set, we used a Azure OpenAI model to create a vector embedding for each row in the data set and appended that row into the table. Okay, so that's what we did. Then what we got is that we got a search text and other filters. We send the other filters and we find a subset of the rows after applying filters. What we did was that we took the search text and converted that into embedding. I mentioned to you that large language models, but they only understand numbers. So I had to convert the text into numbers, and that number goes there, compares to other numbers, and then I get another subset of rows through similarity search. Another subset after similarity search, and then what I end up getting is that I join these two. What came from similarity search, what came from the search. Join, in this case, you don't need to actually do a join because it's coming from the same set of tables. But think of this, that you got 2 separate data sets and then you join them. And then you send that to LLM, it can complete the result and package it the way you want. Now, interestingly, so we added relational filters to similarity search to create a hybrid search for you. Now, the world is even more connected. I just don't want to eat any good reviewed focaccia bread somewhere. I want to go only if you have gone there, right? Or any of your friends have gone there, because I trust my friend circle. I trust the people I work with, I trust the people I socialize with. Anybody's choice is not my choice. So what you can do actually is that you can actually, again, because the data has interconnected graph relationship between that, you can extract that graph relationship, build a knowledge graph. Obviously, you need to use a database that is capable of building knowledge graphs. Thankfully, the database that I build, Microsoft Azure SQL, can do that. And what I'm going to do that, I'm going to use the graph relationship to further narrow down my search, further filter out, and then you can get that. So the vector capability in to do this kind of similarity search, converting text to vector and all these things is in preview in Azure SQL database. You can actually take this and sign up for it and have fun playing with it. The one thing that I must tell you is that anything in Microsoft to do with AI, we follow a very strict regime of responsible AI, because we run on trust. Your data is none of our data. So if you're a user, if you're a developer, you are a customer, you're using any Microsoft product or solution, we don't use your data to do any training. You can see only data, you can use only data. That responsible AI is a ground up policy practice that we did every stage of product development lifecycle. I just wanted to make sure that you understand that. The good thing is that we are in an HTAP event by PingCap. The TiDB will be available in Azure coming soon. So, and TiDB has all those capabilities that I talked about. So play with that that as well. All right, thank you all. I had fun. I hope you had fun too. So I'll be hanging around in the event. So.